This is the last FRQ of the Unit 11 project. Woohoo! Okay, so let's get into it. So first, like we've always done, we're gonna name our relevant equations. It's so obviously we're gonna need that V equals R, and then resistivity or resistance of a conductor. Oops, L over A, and then yeah, I think that's everything we need. So this is a experimental design one. So there's multiple ways to do it. I went through and looked at it but before and kind of got an idea of it. So maybe pause this video, think it through, and what I say that there's always a ton of ways to do this, but what I came up with, the students, is ohmic. Oh, and it's important to know what ohmic is. So it's ohmic if its resistance remains constant across different potential differences, which would mean that it's a linear um, current versus voltage graph. Okay, so we would do quantity to be measured. I'd say the potential difference across lead, and then I'll just say potential diff across lead, and then that'd be the symbol V, and then I'd measure it with a voltmeter. And then I'd also say current in circuit, and that's going to be I, and I'd measure that with an ammeter. And then to determine if it's ohmic, so it's okay. So I'd say so here's what I came up with. So one, I'd say set up a series circuit. Set up series circuit with battery. So ammeter. The pencil lead, and then one of the resistors. And then the ammeter and voltmeter we would use. So then I'd connect the voltmeter in parallel with or I guess across the pencil lead. Across I could also type this instead of write it, but just keep writing. Then I'd record the current and voltage for first resistor. Record oh no. Current, voltage for each resistor. Or Well, first resistor, let's say. And then let's actually, I'll erase this so I have most of this. Okay, and then step 4, I would swap resistor for another value from the provided set we were given of resistor. And that would change the total resistance, and that'd be, so then giving us another data point for I and V. And then I'd repeat until all resistors have been used. And then, yeah. So that would then allow me to, another. So then if I have my data points of I and V, I would, oh, well, here. So that's my procedure, and then I explain how I'm going to use it in C. So I would plot a graph of raw data, um, of oops, V on y-axis, and I, current, on x-axis. And then I draw a best fit line, and if the data points form a straight line, then so if it's V over I, right, so it'd be, and if they form the straight line that passes through 0, 0, then the pencil lead would be ohmic, because resistance is V over I. So that would mean resistance is constant. So if this graph is linear, that would mean resistance is constant. Okay. Now D and E. So to determine resistivity, well, we have to remember that formula. Or, which information? Oh, I guess I just explained D as well. For D, determine which information will be used and how used to determine. Okay, so this, what I answered both in C. So this would be just graph V on Y, and current I on X, and then this would be, I'd use and see if this is linear. If this graph is linear, then I know it's ohmic, because if the data points form a straight line, then that means our resistance is staying constant across changes in voltages. And now E. Oops. Pen stopped working. After completing their conclusions, the student find that their pencil lead fit the model of an ohmic resistor. Okay. But other lab groups determined the lead was non-ohmic. Explain what experimental factor could explain this difference and explain your answer. Well, I'd say a temperature change. So if the group left okay, so the group that found it to be non-ohmic, it could have been temperature. So if they left the circuit closed for too long, then the current would heat the pencil lead, and then that would then increase its resistance and cause the V versus I graph to be a curve instead of linear. So they could have measured it to be non-ohmic because they altered the resistance of the pencil lead through their experiment by leaving the battery on. And okay, so that means in our procedure we should have written I should have written like as the last step, turn off battery at end, like cool down until I repeat, to prevent changing the properties of the pencil lead. So yeah, that's it. That's the 10th FRQ. It's been a pleasure, and that's it. I'm signing off. Thank you.